10B, we're going to look at outliers and influential points with our scatter plots. And so to do this, we're going to revisit our Barbie example. So how safe is Barbie? So here we have some example data from one group, okay? And the question is, how safe do you feel Barbie's jump would be if we use this data? Okay, so here's the data we have. How confident do we feel that this data would be good to predict a much larger jump? Well, one way to answer that is if we look at this scatter plot, this data looks pretty tight. I could draw a line almost exactly through all of those points. Um, and then if we look at the information from Desmos, my line of best fit, and especially my correlation coefficient, 0.9924, that is pretty darn close to 1. So that means this equation almost perfectly describes the relationship between these dots. So these dots, if I were to graph this line, these dots would almost line up perfectly. If my R is close to 1, I would feel pretty confident that Barbie's jump is going to be safe because the line of best fit matches very, very closely with my data. Okay, now we're going to look at two things. We're going to look at outliers and influential points. So an outlier is any data point that is significantly different from other observations. So it's a lot higher, it's a lot lower, or it doesn't fit the pattern. Okay, an outlier is an influential point if it has a large effect on the slope of the regression line. Okay, so we're going to look at one example. A group snuck some extra rubber bands in. We only give you guys 7. They got 15, and with 15 rubber bands, Barbie fell 49 inches. All right, how do you think that information would affect our correlation? And so here I have graphed it in Desmos, and you can see it's an outlier, right? It's far away from all of my other points. However, it fits the general pattern, right? If I were to extend that line that we drew between the dots, that dot fits the pattern. If we look at the line of best fit, the slope is 2.494. In our original data, the slope was 2.476. That is not a big change. All right. The correlation coefficient is now 0.998. So if anything, that outlier made my correlation even stronger. All right. It got even closer to 1 because even though this data point is far away from these, it matches my pattern and makes my pattern even stronger. So now that group that cheated and used 15 rubber bands has made me even more confident that my equation is going to be good to predict how many rubber bands Barbie needs to fall. All right, and then one group member has some different data. They're like, wait, no, I have 6 rubber bands being 6 inches. Okay, how do you think that is going to affect our correlation? Okay, and so for this one, I took out the 1549 and went back to the original data, and I added in 6, 6. Okay, as you can see, this is an outlier. All right, it does not fit the pattern of the rest of my dots. The new line of best fit with this point included is y equals 1.521x plus 12.921. All right, remember our original line of best fit was 2.476. So from 2.476 to 1.521, that is what we would consider a significant change. Okay, so that is a big change in the slope. All right, and I would call this outlier an influential point. Look at our correlation coefficient. Before it was 0.99, now it's 0.499. It has dropped significantly because this line can't really match all of the dots when we have this outlier down here. Okay, so that point of 6 rubber bands and 6 inches, we would call that an influential point. Okay, and then here's the important question. Should an influential point be removed from the data set? Okay, should we just take that out because it doesn't match? Well, the answer is maybe. All right, or It depends. Well, what does it depend on? Okay. You have to have a valid reason for taking it out, and it doesn't fit the pattern is not a valid reason. Okay. Most of the time, if we have an influential point, we would say, here's the correlation with the influential point included, and here it is if we take it out. Okay. The times that we can take it out would be is if it was collected under different circumstances. Okay, so what happened with that Barbie that only fell 6 inches with 6 rubber bands? Did the rubber bands get stuck on something? Did the person dropping her not do it properly? Did we measure with the wrong, side of the yardsticks? Different things like that. If there are things like that that happened, you can remove the influential point, but you can't take it out just because it makes the correlation weaker. You have to have a valid reason besides, well, it doesn't fit my pattern.